right, so we're going to be doing the factorial challenge. So I've cloned that down from my GitHub after forking. I'm going to go into that directory and then open up a new code window. There it is. And move it over here. All right, so we're going to do this in Python first, and then we'll see how we do it in JavaScript and see if there's any differences that we encounter. So for Python, bring up the spec file, just see what we have. Yeah, so factorial definitely gets really large really quick. So 45 gets to whatever number this is. I'm not sure. Is it quintillion, septillion? I don't know. Okay, maybe let's add a couple more test cases. So print factorial of 0. I believe that special case is equal to 1. Print, what else can we do? 3. So 3 is going to be 1 times 2 times 3. That should be 6. Right. Okay, there's a couple. Let's add a intermediate one here. So let's do 24. I'm not going to compute that in my head, so I'm going to have Google do that for me. Factorial 24. I need scientific. How do I get scientific? Calculator soup. I want 20, 24, I think. All right, there's our number. All right, that should be good enough for my initial testing. So we handle a special case of 0. Maybe we could do 1 just for good measure. 1 should equal 1. All right, so now we have this. Let's run our test cases and see what happens. So clear. We need to go into my Python folder, Python, and let's run our test cases first. Let's see if we pass any. So I'm going to do Python factorial spec.py. All right, we get an error because we actually need to have legit code. So this is the pass keyword that I talked about before. So if I add a pass in here, this is going to basically say this function has no functionality. You can't just omit and not have any code here. Python's going to think that you left out something and throw an error. So if I add in pass there, now my function exists, has a definition, and that definition is nothing. So I go back to my test cases. All right, I'm failing all my test cases. That's not much of a surprise because I have no functionality, but it seems like my test cases are running, so I have something to go off of. All right, so let's talk about factorial. Let's look at the README over here. How would it go? Factorial. All right, factorial, in this exercise, you're going to create a function, takes in a number parameter, returns a factorial. So again, if you're not familiar with factorial, it's just a mathematical, I guess, operation where you multiply numbers from 1 to n, and the product that you get is the factorial. Again, 0 is a special case, so the factorial of 0 is actually 1. It's not 0 times 0 or whatever, or 0 times 1. It's going to be 1. So let's kind of code this up. So talking about factorial, it's going to be, let's say, a for loop for I, let's do it for n in range. So again, range is a nifty function in Python. This will go through values of 0 through up to, but not including num. So that's not quite what I do. Maybe I'll do a +1 here. And I don't want to start at 0, so I'm going to start at 1. So that's one way I could do it. Another way could be I could start at 0 and add 1 multiplication. So let's go that way. So we're going to need some product that I'm keeping track of. So we'll do products. Let's call that vector products. And start that at 1, because since I'm doing multiplications, I don't want to start at 0, because anything times 0 is going to be 0. And then we'll do products, products times n plus 1. Again, you got to remember your order of operations. If I leave it like this, it's actually going to multiply the product by n and then add 1 to it. So always good to have parentheses. Sometimes they're required. I always do them even when they're not required, just to make it more clear. In this case, I'm adding 1 to n because n is going to start at 0, and I don't want to have that 0. And then I'm going to multiply that value times my existing product. And so I have some tabbing issues here. Okay. Product. All right, and then we want to return product. Theoretically speaking, we don't need to do it for 1 because 1 times anything is going to be itself, but I'm going to leave it like this and see what we get. So, okay, let's give this 1 and let's see what happens. We got true. Why did we get true? Okay, so for 0, we kind of inadvertently handled the case because if num is 0, our product's going to be 1, and this for loop is not going to execute because we're going to go from 0 to, I guess, 0. So that's not, this for loop's not going to even execute. So we're going to return 1 in that case. So coincidentally, we handled the 0 case, even though I omitted that from my logic. But we ran that. Seems like it's working. Let's try some bigger numbers. So let's drop in a 50 here, not get too crazy. 50, and what is 50 factorial? Can this do this? All right, some super large number. Question is, do you think this number is larger or the number of, let's say, stars in the universe? I don't know. The universe is huge. I can't even conceptually think about numbers that large, so I'm not even sure. Let's do a quick fact check or checking that out. So stars in the universe.
Wish I had that many digits in my bank account.
Pretty sure that amount of money does not exist in the world. Number of stars in a galaxy varies between 100 billion per stars. Okay, so much smaller. I guess the galaxy, again, large numbers. It's hard for me to guess it, but apparently there's that many stars in the universe, approximately, obviously. So it's some factorial number. Let's see if how big it is. Let's get rid of these commas. All right, so it's less than 24 factorial number of approximate stars. So maybe like factorial of 22 might take care of it, 23 even. I'm not sure how fast it scales, but somewhere between 18 and 24 factorial is how many stars we have in the universe. Good to know. All right, let's do factorial 50 quickly, make sure Python doesn't choke on larger numbers. All right, we still got a true, so I'm pretty confident that this is working. We could add some error handling, so that's another part of writing safe code. So what if we pass a negative number here? Would anything break? I'm unsure. So this should theoretically return none, because factorial -1 I don't think is legit, is it? Let's see what this calculator does for us. Yep, it error checks for us. So in this case, I would say our function would return none, or some exception, but I'm going to go with none. So if I ran this, we get a false because we didn't return none. So we could probably quickly check that if num is less than 0, return none. Okay, does that take care of that test case? Yep, that looks good. Also, we could check if we want to get more advanced. Again, we don't always have to do this, but what if we did like, non-integer numbers? In this case, it looks like it rounds, but I don't think factorial of 1.1 is a valid case. So we could do something like if num is not, or sorry, is instance. How does IsInstance work? So there's something, there's a function in Python called IsInstance. So let's learn about that. IsInstance. We can type. Let's read what this is about.
We're getting like type checking here, right? Where you're like checking to see if the input is not a num and instead is like a string or a float.
Yep. So in this case, we have this handy IsInstance function that I can check if a given value is a given type. So in this case, for their example, they're checking if 5 is an integer. In this case, that should be true. So let's run this code. W3 schools is kind of slow, very slow. All right, we get a true. What if we had a 5.1 in here? Would this return int? I would expect it not to, because that is a float. Yep, so we get a false. So we could use IsInstance to check what we're looking for. So we do IsInstance num. We want to check if that's of type int. And then if that is not true, so I'm going to negate this, we'll return none in that case also. And I forgot my colon, which I do like half the time. All right, so that will check where I have bad input. So let's say I pass in a string of donuts. That should be none also. If I pass in a floating point value, so if I pass in, like 4.5, that should be none also, because technically Factorial requires integer inputs.
So, Ankur, I have a question.
Yep.
Back in our Factorial.py, would it make sense to have the is not instance first above the 0?
Yeah, so I just ran into that error. So again, I didn't code this up perfectly, and we got an error. The reason being is because I have a string example, and that's actually going to try to do this comparison first before checking the type. This comparison is only valid for ints, because I'm comparing one int, and the other side has to be an int. So definitely should swap these, because we want to check the type before we do a comparison with the type. Is that what you're saying?
Yes.
Yep, you caught that before I did. But yep, now we made that switch. So the string case gets the correct none return because we check the type on line 2, and then we do a comparison for negative values for integers. All right, so that's our factorial function. Again, we added some error checking, not always required, especially for simple channels like this. But when you're writing actual applications and you have user input, you don't want to trust the user to be sensible. Either they could be malicious, or they may just be not the brightest and might put in wrong values, or maybe you didn't specify the requirements and they just wanted to try it. Okay, so that's Factorial in Python. So let me do a quick incremental commit to my Git. To git commit and completed Python solution. I won't do a big push. All right, so that takes care of Python. I know the original request was about JavaScript, so let's actually quickly do that. So we have JavaScript, similar spec file. I'm gonna be lazy here and just copy over the test I had. And let's see if we can pass all these tests over here. We will need to make some changes. So we do a find replace. Print should become console.log. All right, what else do we need to do? Facts, so factorial should be factorial. Okay, I think those are only changes I need. None needs to change. So there's no none type in JavaScript. The equivalent is null. We might want to return undefined in some cases, but we'll assume we'll be returning null. Okay, and then so these larger numbers are the general question, because JavaScript, again, has a cap of how to represent integers versus Python, I guess, realistically doesn't have any limit there. So let's save this, and let's run our test cases and see what happens. Make sure we have something here. All right, that's fine. So I need to get to my correct folder. So I'm going to do a quick shortcut, Control-T. And now we're in our JavaScript folder, so let's run node with factorial spec.js. Okay, we got a module not found. Why did we get a module not found? Cannot find module fact.factorial. It's because I did a bad find and replace here. So that is my bad. All right, we ran some of our test cases. Looks like we passed it for the first 3. I think that's accidental, because since our factorial function in JavaScript is not returning anything, the default return value is null. So accidentally, we're passing these test cases, but that is not what we should rely on once we actually code some stuff in there. But otherwise, for the normal cases, it looks like we're failing all those, which makes sense because we don't have any logic in our factorial. So let's actually change the results of those. So here, we're going to do something very similar to what we did in Python. Let's have our product value. Start that at 1. And then we're going to do a for loop. So let's I equal, I'm going to start at 2 because I don't care about 1. I less than num plus 1. Okay, so this is one way we could do it. Products would equal I. So again, asterisks or multiplication equal sign, that's just another shortcut. Same thing as plus equals. Instead of writing product equals product times I could just do times equals. We could do the same thing in Python also. I chose not to. In this case, I just did product equals, but I could easily do this as a shorthand. All right, so products times I. Let's return the product and products. Okay, so we're counting upwards. We're starting at 2 because 1 times anything is going to be that anything. We're going to num plus 1 because we want to include num. So we could maybe just do it equals here instead of plus 1. And we're incrementing upwards, multiplying our existing product by that value, and then finally returning our product. All right, any questions on what we're doing here? All right, let's give this a try. On my spec file. All right, notice I'm failing my first 3 test cases. That's because we're no longer returning null when we should be. So again, we're passing those test cases early on accidentally, not intentionally. But the rest of our values here seem to be good. All right, so we did factorial of 50. Andrew, I think you were initially asking about the JavaScript. Was there a value that was failing?
Yeah, for me, let me see which one it was. Yeah, 45 failed for me.
45.
All
Okay.
the rest of them passed.
All right, so why is this passing for me is a question. So one thing, I know Chris, when I was talking to him last cohort, he did notice that if you reverse this, if I start at num and then count downwards, the result might be different. So let's actually try that.
Yeah, that's the one that I did.
That is precisely what I did and caused the same error. I had to use like big int to solve that.
Yep, so there's a big int type. I think I did use that at some point, but it is curious. And I'm actually curious about this also. So we basically reversed it. So essentially we're doing the same multiplications, just in reverse order. So we're doing our largest numbers and then multiplying with smaller numbers. So we're starting at num, going until I is greater than 1, and we're decrementing. And we're doing the same multiplication because that's what we want. And let's run this again. Okay, so we still are failing the first 3 test cases. We need to handle those. We pass all of these, and surprisingly, we pass the 50 case, but we fail on 45. Why is that happening? That's a great question. I don't have a great answer at this point. Again, with large numbers, things get kind of weird. So maybe there's some, again, rounding issue happening with large numbers, like we do 45 times 44, and then get to 43 times 42. Once it gets to a certain point, it might chop off some digits. That'd be my best guess, but that is definitely curious. So if you guys ran into that, that's kind of like a odd peculiarity. Again, if we flip these, so if I again go back to I equals 2, flip this to less than equal to num, and increment. Somehow that works. Why does that work? That's a great question. I don't have enough in-depth knowledge into what's going on with those multiplications, but again, large numbers, things get murky with JavaScript than most other languages. Python is more reliable in that sense. Jack did mention something called BigInt, and that is something we did not talk about specifically, but this is where your research can kind of help you. So Google is your friend. So let's say how to handle large values in JavaScript. Let's see what Google tells us. All right, this looks like what I'm looking for. So in JavaScript, it's telling me that the limitations of int is this maximum value. 2 to the 53rd value minus 1 is the largest int it can accurately represent. If we want to go larger, it looks like there's something called BigInt. So BigInt is just a different type. Looks like we declare it by using BigInt like this. And then, okay, let's give this a try and see what happens. So BigInt here, I think. And BigInt here. All right, so my input is going to be a BigInt value of just 45. and I want to keep these types the same. And then I'm not sure if this is going to work because I might need a
I think it'll break down because you're mixing big int with int. You can't do that. You have to be like all in one space or the other.
Yep. Yeah, so this is going to be a little different. Let's actually just create a new function so we don't break our existing functionality. Let's call this big factorial. For lack of a better name, this will all use big ints. So anywhere I'm using an int, I'll use big ints. And let's see if this resolves my problem. This is going to be a big int input. Okay, I think this should work, but I'm not sure. So
I think the on the duplicated function that you made, we were decrementing instead of incrementing from one.
Right. Hey, that is a good point. So we start here at num. We want to go until this is greater or equal. This is greater than big int 1. And decrement. All right, let's see if this works. I'm curious. So we're going to use big int here, or big factorial here. Big int. Okay, and we need to include big factorial. We're exporting it in the exports module. So let's give this a spin, see what happens. Okay, we still get a false, so that didn't solve it for us. So actually print out the value here. And yeah. So we get a...
It's expecting an n on the end because big int numbers are ID'd by that tailing n.
So even though I converted this to big int here, it doesn't work?
You'd have to cast it back to num and stuff. Yeah, it gets weird.
All right. Interesting.
Yeah, like the way that we implemented it was that like everything coming in was big int, and then right before you return it, you would turn it back into a number with a capital N, and then parens around your variable, and then it would just return as a straight number.
Okay. Yeah, I guess I'm not sure why equals wouldn't work with that big int, but yeah, if I put an n at the end of it, it converts it to a big int. So it looks like I'm passing that test case now using big int. So again, definitely a bit unexpected functionality with JavaScript there. It is odd that factorial 50 would work, even though when we did the decrementing way, but not 45. So yeah, at that point I'm like, yeah, that's surprising. Definitely not. Don't have a good explanation for that. But yeah, that just, again, kind of highlights some differences you might get with working with two different programming languages. Just be aware there might be subtle cases where you get different values. Like obviously in JavaScript, we have undefined. There's no real way to represent undefined in Python. So everything will map to none, I guess, in Python for null and undefined usually. But in JavaScript, you're going to have two separate values. So you might want to write test cases a little differently based on that. Let's quickly handle these three cases because we've not done that in JavaScript. So I'm just going to get rid of my big factorial function. Or I'll keep it. I'm not going to add my error checking there. All right, so let's add some error checking. So first thing we want to do, similar to in Python, we want to check the type we're passing in. So let's figure that out. Trust our Google. So check data type in JavaScript. So there's a type of. Yep, type of. So basically, if you want to check the type of something, you will get an output. You want to compare it. So you can compare it to number. But that's not going to work for floating points. So how do we check if it's an int? All right, so Stack Overflow is a great resource also. Again, it is kind of random people answering it, but people vote on it, usually get like a good solution. So look for that check mark and a lot of upvotes. That will be a reliable solution. So it looks like there is check for remainder by dividing by 1. All right, seems simple enough. So if you do, so it looks like if you mod something by 1, you'll get a floating point remainder, right? So That seems promising. So we'll do if type of num is not equal to number. Again, this was just from documentation. It's not stuff I've memorized. So documentation, I'd say a lot of coding, it's not glamorous, but is reading documentation and making sure you understand, if you're using APIs, you understand how the inputs and outputs work. Any functions you're using, reading documentation definitely goes a long way, especially if you're not familiar with that function. Like I don't use typeup very often, so I need to check, how do I actually compare it to numbers? So looks like lowercase n, not uppercase, and make sure that's legit. So then we'll return null in this case. So again, if we get a string, if we get like a list, if we get anything that is not a number, we'd want to return null. So that should take care of that. But we have an initial case of if we get a floating point number, what do we want to do? So if num mod 1 is not equal to 0, so mod will return a remainder for floating point values when you modify 1. So in this case, not equals. Let's add a triple equals here. Return null. And then assuming it is an integer, we want to check if it's less than 0, return null. Okay, so those should handle, I guess, the 3 test cases that we had. If there's more we want to check for like that input, we definitely could.
I think you need the curly brackets for, I think you're doing Python right now for.
Around here. Yep. So definitely good practice to have those. So I will add those in. Just remember, you might see code without those curly brackets. Like if I have something like this is totally valid. The only reason it's valid is because whenever you have a single line expression in your if body, those curly brackets can be omitted, and JavaScript will be fine with this. But again, that's dangerous because if I add like if I do something like this, console.log donuts. Now, if I do something like this is not actually going to work like I expect it to, because the way JavaScript is going to interpret this body of code is actually, it's going to imagine curly brackets around that, and then this is going to be outside of that if. So again, always good practice to have those curly brackets, even if you don't need them, just because when you might add more code, you might accidentally code something up incorrectly like I had before. Like again, this is not going to be valid, or it's going to run, but not do what I expect it to do. So good point there. Definitely here. So let's add those in. I will get rid of my donuts for now. Okay, so we have some error checking. Let's see what our output does here. Okay, we are passing those first 3, and we did not break any of the other test cases. So it looks like our test cases, for the most part, work correctly. Again, that big int exception, we could probably add this logic there, or create a new shared function that has similar functionality and maybe uses big int when it needs to. Again, many ways to go about it, but for now, I'm just going to be satisfied with what I have here. I guess just to be sure I do this here. Let's see if that catches any mistakes. I have big int of -3. Will that work fine? No. All right, so big int -3. Let's see if this check still works for big ints. Hopefully it does. Maybe I need I think this is actually not going to work. Well, let's verify that. That works. Do I get a false? Do I get false? Let's do type of big ints. All right, so I got to check big int instead of number, so that's one difference. Big int. All right, so I got an error as I expected. The reason being is I'm comparing a big int value to an integer. They don't allow you to compare different types, which is surprising for JavaScript, but JavaScript actually complains about that. Most of the time it silently fails.
Also the one.
Where that's here. Okay, so again, big ints, the notation of if you tack on an n to an integer value, it's going to convert it to a big int implicitly. And this is one of the few times where JavaScript actually yells at you rather than failing silently. So it's kind of good to see. But okay, we made some error. We added some error handling here, so that's it's a positive, not necessary in our requirements, but just good to have that additional safety net. Okay, I feel like I'm satisfied with this. Any questions on our JavaScript solution or anything? Any questions about big int or anything that doesn't involve Factorial 45 that I could try to answer?
No, just a comment. I just need to Google more.
What was that?
No, so it's just a comment. I just need to Google more
Yep.
because I was able to solve some of the problems that I was like, just seeing how people are thinking and the way they're asking questions. They're just Googling more than me. Like,
Yep. So
that's all they're doing.
Yep, absolutely. Googling is not bad practice, but you want to make sure you're Googling, I guess, in a smart sense. You don't want to be Googling, how do I solve factorial challenge? That's not teaching you how to solve the algorithm, right? That's just teaching you how to copy and paste an answer. But yeah, if you run into an issue like, hey, how to deal with large numbers, that's totally something you should be trying to do. It's like, it's not going to be easy to figure out just on your own. So Google definitely is a resource, and we highly recommend Googling often, but just make sure you're Googling for specifics, not Googling for general answers. If that makes sense. So solve JS solution here. And we'll do a git push origin now. Okay, so we pushed up both our commits. So our first commit was for Python, second commit was for JavaScript. Pushed both of those up to GitHub. So let me quickly go back to my GitHub, do a quick refresh. So my timestamps look correct. Yep, 20 seconds, 19 seconds, that looks good. Let's do a quick pull request submission, and then we'll take a break after this. Okay, create pull requests. I'll check, make sure there's no errors. All right, looks like it's good. And that takes care of Factorial. All right, with that, we're hitting 10 o'clock. I know we didn't take a break between the challenges there, but let's take a nice break here. So let's take a 11-minute break. Please be back by 10:10, and then we'll dive into talking about test-driven development for today.